So continuing our journey this weekend, we're going to have a very respectable world-class researcher, Dr. Aditya Sood, and he's going to be speaking about exploiting embedded web security. So please, let's welcome him. You can try to take it off. You can hold it like this. There you go. Yeah. See, it's good for you? Yeah, I'm sure. Yeah.
Let's get it started. Welcome everyone. I appreciate the fact that you guys are taking time on the weekend and attending this talk. And for the next, I think 45 to 50 minutes, we're going to make it really good. So what we're going to talk about today is the world of connected devices, exploiting the embedded web security. So in this talk, we're primarily going to focus entirely on the fact of embedded web security. We're not going to go too much deeper into different set of components, but rather than focus primarily on the web security. And during the course of this talk, you will realize, how the vulnerabilities exist in these systems because of the security flaws that are existing in a period of time. But in this particular talk, we're going to focus from what we have seen in the history, where we stand with respect to that right now, and what we're going to look into the future. So we'll take a couple of real-world case studies about different malware examples, look into what we have discovered in the wild, whether it's in the context of SCADA devices and all that. But it's all connected on the internet, and that is the most important part. We're gonna look into it. So before moving further, I really wanna lay a little disclaimer, and the reason for that is because in this particular talk, we're gonna touch on different research artifacts, right? Considering that there's all this thin red line between, so it's better to just dissociate from whatever you're working right now, and then because of security community, we're gonna whatever the contributions we are making to the security community, that is the most important one. So nothing related to any of my previous or present employers, just for the community. So little background of mine, just try to give you an idea that if you are somebody who's delivering this talk, he has invested a good amount of time in the field and knows what we are going to talk about today. So you can have a little link to my portal if you're going to do the little background search, that's totally fine. But let's get it started here. So what's the agenda going to be today? So we're going to take a look into the connected devices present scenario, current and the future state. We'll look into the security and threats entirely into the embedded web security space. We'll go through the real-world case studies, starting from the vulnerabilities, then malware analysis, and then at the end how the bots are being built. And then at the end we'll take a look into using all the techniques and the indicators, what kind of SCADA devices we have seen in the wild, basically the web HMIs. And then we'll open for the question and queries. Okay. So before moving further, I think it's really good to understand what we are dealing with in today's world. If you look at the connected devices present scenario and some of the news portals, what we are talking about, you get a clear gist of it, in which world we live in. Data movement, increase in usage of devices at an exponential rate. And even in this thing, the threats are increasing as well. If you're talking about millions or billions of devices that are connected in nature, so we need to understand how the threat landscape is going to evolve with that as well. And that is the most important part we really need to look into. The launch pad for triggering attacks is increasing at a rapid pace. But that is a reality we live in. We live in the world where we are dealing everything through internet, but we really need to understand it's not all about the data movement between these devices, but also at the end of the day, it's more about what kind of threats we are carrying with it in the mobile space. So let's take a look into the connected devices current and future state. Why this is a very interesting problem to look into. If you look at from the 2015 and try to get into the idea of by 2025, how many devices we are actually going to deal with in the billions, right? And this actually gives you the idea that this thing is increasing exponentially. Every year, we are dealing with the problems from the existing year, but the next year, more devices are adding up to the system. And how they are communicating between each other, how they are acting as a launch pads, how attackers are going after them, building strong botnets, and all those sort of things. But this is a realistic problem, and we really need to deal with that in a serious way. Okay, so what we're gonna talk about today is, if you look at the connected devices, if you do the kind of either security modeling or threat modeling, we really need to dissect the state of devices, which means that we really need to understand what kind of different components that persist in that. So we talk about authorization boundary, where these devices are located, how the data movement is being happening, authentication, authorization controls, and all those kind of standard security parameters, network, encryption, software code, update mechanism, so and so. But the focus today is that embedded web security. And the why reason for that is because this is one of the primary component that actually persists and has been basically shipped with most of the devices that are actually available on the internet. And which means that, of course, we are dealing with the HTTP protocol here because of the web interface. And then at the end of the day, on the internet, most of these will either be exposed or not secure. But one or the other way, if you have the ability to find the indicators, you can actually go ahead and actually find these devices on the internet, which means that there is an interface that is available to you. And at the end of the day, it's all about how you're going to go after it if you want, or understand how you want to perform the research. Now, next step is the why embedded web security. So if you look at the different, if you put a little with granularity in that and try to dissect the web security, we're going to talk about the different things here, like there's a buffer overflow in web components, cross-site scripting, and those kind of things. Which means that, look at this from a statistical point of view, the different kind of vulnerabilities that exist simple in the web component. And that we really need to look after. And when we're doing research, we have to focus the state of the research. We just cannot go too broad, because then you lose the touch, and then whatever we want to achieve out of that research is just not that impactful. So the idea is that let's just concentrate on the web component and take it from the vulnerability way to the malware analysis and how malware has been being using these vulnerabilities, and then at the end of the day what we are seeing on the internet. And that's the target. So let's move further. We're going to look into the embedded web server threats and security. So different kind of security issue that can exist in this world when we talk about web server security in that. But we're going to talk and concentrate on that based on the kind of vulnerabilities that we have seen in the wild. So what we have seen exactly, how you can bypass browser-based JavaScript restrictions, right? For example, you're opening up a web interface of a router and you're clearly looking into it, and they're saying there are some security mechanisms deployed in it, but how you can bypass it. Of course, the insecure password storage, we look at it, how they actually go after it. Of course, weak cryptography is a big problem, and we're going to talk about how that kind of issues will actually, basically compromise the web interface. Credential leakage, unauthenticated web resources, injection attacks, and cross-interface attacks. I think the cross-interface attack, you'll love it, because in that sense, we are actually going after attacking a device from a different interface, and then we're going to talk about how exactly that is important. See that in this kind of scenario, this is also helpful when you're actually going after doing penetration testing or security assessments in every space. It just cannot only be directed towards IoT devices, but you can actually go after different set of web components when you're going to perform some kind of security assessments. Now let's talk about real world case studies. So when I talk about real world case studies, this is just like a real world devices that we have found on the internet and some vulnerability research that have been conducted. And this actually talks about like whatever the security issues we are talking about are real, and under the responsible disclosure guidelines has been reported back to the vendors, they have fixed it. But from intelligence perspective, is really required to understand why we really need to perform this kind of research. So let's take a look into the browser-based JavaScript controls. And we have seen that this has been implemented away, because when the developers think about it's just web embedded security, where we really need to go after implementing strong protections. We can actually go a little bit here and there, implement shortcuts, and then take it from there. But then again, it becomes a nightmare down the lane if somebody finds it out, and let's take a look into it. So the idea in this case is that what we have seen, let's say you open up a web interface of any, basically IoT device, whether it's a router, switch, or any kind of other device, right? and you're seeing that you're providing some, you're interacting with it, providing username, password by login authentication component or any other kind of thing. But what we have seen is that if the arbitrarily provided input value is not good, it's just actually going to trigger an error notification. Totally fine. But that is only based on browser, because at the end the web server is actually actually looking into the fact that you're opening the interface in a browser. But what about the other kind of utilities that we have, whether it's a curl or wget? Let's take a look. So this actually gives you one of the interface. So when we're trying to interact with, we're trying to access a system information file with an extension of .gch, and you can clearly see we try to get that path after research, and we try to put it in a browser, and they actually found that there is some control is being implemented which is restricting the request to go through. So they're saying timeout, please log in again. Totally fine. So which means that as a part of the research we are not able to get access to that path. Totally fine, but we really want that resource. So what we're going to do next time, because of threat modeling that we have done and the security boundaries that we have checked, we're going to change our attack vector. What we did is the same attack path, but we have changed the client. So you can clearly see with the curl and wget, when you issue that request, it went through, and you got an access to their system information file and all the details. Interestingly, they are also talking to you and give you their password on the client side as well, on the other side there it is. Which means that now, after understanding the way that device is working, it has an embedded web server, application is there, exposed on the internet. And then you find it out of ways, little bit scanning or maneuvering manually, you get an idea that there are some resources there which can be very, very critical. And then you start testing, and you can clearly see all the browser-based JavaScript protection or bypass, because whatever that request we issued is never been by browser. It's by curl or wget, and they actually went directly hit the web server resource, and then there is no client-side mechanism there to actually detect it. So you got access to it, you got a password, and then basically, as I mentioned, the password disclosure, you got an access to that audio video conferencing device, and then you got a full control. That is a one way. In this case, we didn't know about all what we have is, the device was exposed on the internet, and we started doing our own research. We reported to the vendor, that's totally fine. But this actually highlights the fact that performing security assessments of these devices, how you have to go step by step. We started with one thing, but then actually we go after and changing things one by one and try to see whether all the cases have been validated by the embedded web server. But that was not the case. Anyhow, CAPTCHA implementation, JavaScript based. So we have also seen that because of course we have to restrict the automation attacks. CAPTCHA is a way you say we want to detect whoever is interacting with that web component should be the same identity or some manual behavior should be noticed in order to make sure that that is a key. But what is the problem that we have seen in these IoT devices? CAPTCHA code is hard coded. And I'll show you, and it becomes a problematic scenario because on the web front, it looks like you're providing the asking CAPTCHA, and then you have to enter the CAPTCHA, and then you actually go and log in into the web interface. But that was not the case. So when you start looking at the backend and try to understand how the CAPTCHA code is generated, it gives you this idea. So this is a case study I want to highlight. So look at this as a router web interface here, and whenever we try to interact with authentication component, providing username and password, it actually gives you an idea here. They need CAPTCHA. That is totally fine. So what we're going to do next? We're going to look at the HTTP request that has been sent to that embedded web server. So if you look at on this part, it is saying CAPTCHA code to supply in this one. That's a totally a standard way of asking for the CAPTCHA code. But if you look at this particular thing, what was happening? If you look at just in the JavaScript code, it was saying all the standard request parameters, but they hard coded the CAPTCHA code here, which means that whatever the CAPTCHA code you provide, they actually send up a one standard thing to the backend server, which means now you know it with what kind of that code is, which means you bypass it, right? And in that case, it looks like there is CAPTCHA, everything is good, we have implemented security, but the question comes to play, who performed the QA checks, who performed the security assessments? But that was not the case. So when that happened, in this case, we are able to, trigger the XSR request and all that, and let it through because we know the hard-coded thing, and it all went through, and you can bypass the, whatever the mechanism for preventing automated attacks. But again, it was JavaScript-based, but they never knew how the captcha needs to be implemented. Every time you access the web interface, the code has to be generated on the server side, fused on sent it via JavaScript or a web page as a part of document object model DOM calls, but that was not the case. But interestingly, you can use these kind of techniques whenever you're performing web testing, and then it actually gives you a different view of it, how the server-side technologies work and all that. Now, another interesting thing we found out is one of the biggest vendor, the issue still reported to them, but it was a kind of weak cryptography and insecure tokens. So it's a part of case of a session management. We all know, when the cookies need to be, generated, they have to be really strong, and then random factor in that it should be high to make sure that it's not guessable, not trackable. But that was not the case in these devices, because the way they're saying, again, the very simple factor in the IoT world is that who's going to attack us? So people never thought about 7 or 10 years back, like people still going to target these devices. Nobody cared, right? So some of the things still got inherited with the same mindset, and that is a problem. These days, like, if you're on the internet, think about you're compromised. And that's how you have to start with building security mechanisms. But let's take a look into this case study, the weak cryptography one. So I'm just going to give you the idea. This is a tool we created, and I'll explain that issue later. What we have seen that in one of the device category of the devices, the way they are generating session token is just like a 4-digit thing, right? Just a 4-digit number. How hard it is to crack it, right? How hard it is. It's not a big deal. You just go with a Python code, we develop this code and all that, and then we constructed the same request wherever the hard-coded parameters are totally fine. What we need is that with every request, we generated all the list upfront, which means that when we trigger the request, you can clearly see, in this case here, the challenge ID was just only for 4-digit. And that screenshot actually tells you when the script was running in an automated fashion, we are able to dump the configuration file, which has the password in it, without login, without any authentication, because we know what's the valid session gonna be, because the way it is implemented in a very easy way. Which means that now you have the password, it's compromised. But that's all into the real world case studies, what we have seen. These are the realistic devices. For this one, this has been deployed on a wide scale. Don't want to go into the vendor details. Maybe somebody might have already figured it out, but I just avoid that. So now again, the point is the cookies, right? It's a very simple thing, very basic thing, but I always believe that basics are the hardest part to conquer. You can tell me, you guys just implemented MD5 hashing, for example, right? It just has a collision problem, but people are still using it somewhere, some point of time, right? So similarly with the cookies, you can say that when the cookies need to be generated after validating the authentication component, you need to make sure that cookies have your standard parameters. These kind of flags should be their HTTP only secure flags, but the random identifier with the session token should be good. But irrespective, there's a difference between what you propose and what we see in real world, and let's take a look into this one. So when we try to give another thing, and you can clearly see a couple of these devices react very weirdly, whether it's in an anonymous state, or they're running in a default state, or just a really weak password. Somehow, they're not able to change what is coming in the cookie. So you don't use the password as the 6-digit number is all 1, right? And the question is that you have to, in these kind of testing, basic things, but the impact is really disastrous in this case. So with that, you can easily get an access to the interface, and you can have all the components at your stake. Whatever you want to do, one can do it. But look at from the attacker's perspective. If investing a few days into this kind of research and you have figured out all those things, you have to think about attackers are 10 steps ahead of you, right? And they can find it as well. Don't think you found it. It's just like in an arms race, you get a chance to find it a little earlier, but they are there. So might they have already been compromising and exploiting it. So the question is that you have to work with the vendor, make sure they fix these issues. That's the best you can do as a part of security research, but the problems are very realistic in nature. So this is also very interesting fact. It's like kind of getting an access to all the logging files, whether it's the debug logs, warm logs, info logs, or any kind of different set of logs. Access logs, what is how many client ID actually connecting back to the server. So what we have seen that it also suffers from the same problem of implementing a good authorization controls, right? The most important part in this kind of research is you really need to find a way where exactly the log file is being placed on the web server as a part of the resource mechanism. Which means that if you have the full path and you can access that path, then you can test it in myriad of ways. And we have seen it earlier. But this kind of problems persist in these devices a lot. But people, actually in this case, developers, they don't realize in this kind of scenario that disclosure of this kind of information can be really disastrous. Because you can reveal a lot of information about the backend, and that is what is being needed by the attackers. Let's take a look into this one. Similarly, we use our previous vulnerability. So what we started doing right now, we are chaining the vulnerabilities, right? We know how we exploited the first vulnerability, and some other router, a device, I found that thing, and somehow they have the same vulnerability in it as well. So we use the same thing, we know the path, and we dump all the logs. Irrespectively, it's such an information that you get a clear idea how the device is being working at the back end. And that is the root cause of all, a couple of interesting issues, is that, authorization controls. Who's going to access it? If you're not authenticated, why the resources are being placed like a simple file on the web server if you're not restricting it? But that's the real world. Now, of course, nothing in the web security will be, complete without talking about the injection flaws. But I want to start with the stored and persistent accesses. But what my end goal will be really interesting, and I hope you guys love it. In this case, we have seen that the problem persists. The problem is the more complex when the injection flaws become persistent in nature, right? If you trigger one payload, and if it is there and it's staying there in the session, that's a problem, because every time you open the session, it's going to get executed. So similarly, I'll give you the idea. I haven't fixed it. It's a Netcom wireless routers, the industrial routers. You can clearly see it's all getting injected. It's a persistent one, but it's just a proof of concept, which means that we can not need to assume it, but it's a realistic nature. The web interfaces or the web applications kind of being deployed in the context of these IoT devices, they are all prone to these vulnerabilities. But now the most interesting part is the next case study. Which you will enjoy it because it's gonna kind of attacking from one interface to the other, but making sure you still get the payload executed. Let's take a look into that one. We call this a cross-interface attack. I'll give you a little gist of it, which means that most of the IoT devices, there are different remote management interfaces are available, right? Whether it's a telnet, whether it's an FTP, whether it's a web. The idea is you are able to actually access that device anywhere sitting remotely, totally fine. But the interesting part of this security research is that can you actually use one interface to kind of attack the other? Is it possible? Like say, if I'm not able to kind of break into the web interface because they have strong password and all that, can I utilize some other interface like an FTP or telnet to actually detect some kind of vulnerability? And that is the case. So what we did in this tag is, because we had the idea, and to just actually show it, we constructed the proof of concept in that way, but it will make it very clear, how it needs to be done. So take a look at this one. This is the interface, a kind of a telnet interface for some IoT device. You just connect it by 23 or 23 port, and what they are actually giving you username. So what most people gonna do, either launch telnet brute force attacks, right? Username, password, I wanna do that. You tried, but we didn't do that. What we did is, we actually used it to inject web-based payloads, right? So in the username field, I injected some malware.com within a proper iframe header or some HTML tags. But the interface, the telnet interface, still accepted as a part of some string, right? Which is totally fine. But I didn't launch any kind of automated attack or something like that. I'm using that as an input vector to provide arbitrary values. And of course, we triggered multiple things. Now see, so what we did, now we're going to look into the web interface. So in that case, what was happening, whatever you're injecting via the telnet or the FTP interface, it is actually going into the log component of the web interface, talking about who's accessing the telnet interface, right? So in that case, the log component, they never assumed this going to be an attack vector. They never implemented the input validation controls. And what happened? The payload get executed and we trigger the malware.com into that. Because we have the Excel, this is the way to show it, but it all get executed. So you can clearly see you can add process like request forgery uploads, you can change the settings, you can do a lot of other interesting things there as well, because anytime you touch the log component, it's gonna get executed. But the vector is not the web in this case. The vector is this another interface, which is a remote management one. And that being said, I think what we have seen that we have touched on wide variety of other security issues, talking from some authorization, authentication controls, password disclosures, bypassing restrictions, and then at the end, looking into the cross-interface attacks. But now the question that we have to ask when we're doing that as a part of research is, who's going to automate these kind of things, right? That is the most important part, because attackers are not going to go after one set of vulnerabilities. That's not how they build botnets. A collection of bots that are actually designed to build and perform nefarious operations on the internet. So what they're going to do, they're actually going to utilize one of these web vulnerability, launch a broad-based attack and try to see how many get compromised. And let's take a look into that one world as well. So we're doing some research into that context, and what we're gonna cover in this part is like two specific exploits which have been widely used. It's the links router exploit and Hawaii home gateway. And reason for that is what's happening with the 5G stuff. They automate these kind of things. So how we usually as a research community come to know about it. So let's take a look into one. So in this case, what we found as simple a malware binary. I don't want to go into too details into reverse engineering this and that, but I just want to convey the point, how it looks like. So this was an x86 binary, and when you look at try to check the magic headers on it with the file command, you come to know about what this file is all about. So rest part is that when you do a little bit reverse engineering, we try to look at the strings, right? Just give me all the HTTP connections or HTTP verbs that are being used into it. So you can clearly see that when we perform little analysis and all that, when we try to extract the specific set of data, this exploit is kind of hard-coded into it, that binary. Base 64, you can see what the username and the password is, but that exploit is embedded into it. So the idea was very clear. The binary is gonna be x86.bin, whatever, they're gonna place it somewhere on the exposed server somewhere, and they're gonna start triggering the infections. Once any device is compromised, they're gonna start building the botnets out of it. And that is the target, but it's all hard-coded. So once this binary is gonna execute it on any compromised device, it's gonna launch the exploit on the, either a predefined list of targets, or they just discover that dynamically. But similarly with the links router exploit, I'm just talking about variant 1 and 2, you can clearly see all hard-coded, but they are utilizing the web vulnerability into those devices, because either they have some kind of CGI interface and some other things, but the target is actually go after, try to see if we can utilize it. The interesting part is that they have been using the exploits from 2014, 2013, and still they are building IoT botnets at the end of it, which means that you can clearly see how good the patch management process is, or the update mechanisms are. Right. And interestingly, it's really sometimes bad to analyze that still after 5 years, we have so many devices on the internet. But that's still the real world is. So considering that, how can you not gonna talk about Hawaii, right? love 5G in that. Anyway, with that, in this case is that, people are starting exploiting wide home gateways as well. Same mechanism, they know the exploit, they know how to actually embed it, they construct the binaries, which is just not only the x86.bin, but all the different architecture, whether it's the MIPS and all that. And they have it like dumped on a one portal, and once they actually compromise one device, they're gonna start downloading the payloads, execute via that device, and then start adding more and more compromised devices to the network, building the botnets. But we started from the point of the vulnerabilities in the web interface. Now we are into the point like how exactly these vulnerabilities are exploited in the real world, and how they are built botnets and malware infection platforms. Similarly, in this case, just a quick demo to actually give you an idea. You can enjoy a little music as well. There's no fun without music though. Yeah. So in this case is that we were able to find some infections on the internet. We done the binaries with just a basic check. So you can clearly see I done the x86.bat file and I'm just checking the magic header. So it says it is strict binary, which means that you're not gonna find any kind of debug symbols into it. Means that it's pretty straightforward compiled. But you can clearly see that looking at the strings, they have this kind of exploit embedded into it. And then you are seeing not even one exploit, the binaries contain multiple set of exploits in this. And they can trigger whatever the one they want depending on the architecture of the compromised IoT device. And this is all inside a binary. And you can clearly see what's happening here. The post request to trigger the exploit. And this is the whole point to highlight the fact that how the exploits are getting embedded into the binaries. Binaries are spread, and the botnets are being developed. So, of course, nothing's gonna be important not to talk about ransomware, right? Interestingly, this came out in 2018, and but we discovered in the same line. But even in the research field, the most important part is that who's gonna release it first, right? It's totally fine. This is an arms race. Sometimes you do research, but when you try to check it, and you can clearly see somebody else has done it. It's totally fine. The question is not that. The question is that, like, even in 2018, when this kind of information came to exist, HP released advisory and all that. So this is actually an example of HP Oalo systems, the I think integrated lights out. And these are systems are actually infected with ransomware as well. And that is a web interface. So somehow the way it is being done, the compromise happened, the guy actually injected the ransomware notification into it, and these are publicly available as well. The more important, interesting part is that you still find these kind of infections today, and that is what I want to highlight here. So, similarly in this example, some embedded issue in the PowerPoint, but that's totally fine. But I can actually highlight it in the same way. So what we did in that, we actually know that where the XML file is located on that HP system, and we dump it, right? And then if you see it in the next slide, we actually trigger our request and we are able to dump the, this XML file, highlighting some of the interesting information, what kind of version is there and all that. And then we started collecting some more indicators in that. And this is the file how it looks like in a browser. And I have not actually, masked the IP address. I'm pretty much sure if you just open that IP address, you'll still see that infection. Hopefully they are not fixed it, but that's the case. So again, we try to access that thing, and you can clearly see, even with this one, the ransomware infection is still there. Now we talk about a very big organization where the issue have been talked about in 2018, totally fine. Advisories have been released, but this is the world we live in. These kind of issues still persist. And then again, I hope you can try next time as well. But and this is just not only the one instance. There's still many instances in the wild. But anyways, so we covered vulnerabilities, how we actually researchers actually gonna go after discover those vulnerabilities, how attackers actually exploit those vulnerabilities to build malware platform. But now the important part is that when we talk about the connected world in the IoT space, it can't be complaining if we're not going to talk about web HMIs. So web HMI is basically human to machine interface in the world of SCADA environments. And what I'm going to highlight here is that interesting things that we have discovered utilizing the kind of indicators we actually sketched out and what we have seen. So this actually gives you the idea of what is available on the internet and how disastrous it can be even for triggering the nation state attack. The idea is that these things are real in nature. Let's take a look. We'll start with a little thing, but we'll go up by after that. Irrigation controllers, right? Who cares, right? But if these kind of controllers have some kind of functionalities to trigger fish, like sending up SMTP, by emails by an SMTP and support SMTP interface. This is interesting for us because we can utilize the same, compromised device to actually do it. And that's actually attacker go after. That's why you're seeing in certain scenarios, they're seeing, the emails are coming from, smart refrigerators, like emails are coming from these smart devices. It's not that. They just compromise the device. The device has a built-in functionality to support that SMTP interface and go after triggering the attacks. And I think that was the most important part. And they compromised it, they utilized that as a launch pad to trigger a heck lot of phishing emails. But what's your detection? Solution's gonna detect, oh, this is coming from that device, but nobody knows what's at the back end if you go and perform the research. But this is the kind of idea I'm giving you right now. Let's take a look into the next one. Smart IP controllers, right? They are also available on the internet. All you need is to switch on and off. Like you got an access. I'm saying this is a part of the research. You can clearly see what attackers are going after, right? You just switch it off and you can see that impact. And it's all gonna happen by web interface, right? Your input and output status can be there. You can switch on and off and the functionality and the impact will be really interesting. Now, let's take a look at the next example. Industrial control automation HMIs. Would you believe that is a part of the manufacturing functionality? And this is a web HMI exposed on the internet, and what they have? 4-digit passcode. Not a big one, too pretty, right? And there is other mechanism there as well where they actually disclose this kind of information here and there, connect the dots and find it out. And that is one after that. You have a lot of things to look into from security point of view. But the only worry that we have is attackers might have already got a control of it. As a researchers, we just here for the positivity, but you cannot expect the same from everyone out there. Now, another industrial control automation. Did you see that? This one? And it's a water wizard. Don't want to go into too much details, but it actually gives you the idea. It's a PLC controller that has some associated web HMI, but it's used for water wizard things. So you can, stop this fly if you want to. But again, the point is from attackers might already be controlling it. Another interesting one, recyclathon. Same thing. YHMI interface, you have this, and at the end of the way, you have this kind of functionality of their flare buttons, flare it or bypass it. But this is recyclable. All exposed on the internet. So with that thing, I want to a little bit talk about the gist of the talk right now, try to connect all the dots. What we have seen that in the world of connected devices, data movement is happening at a very rapid pace. devices that we are using, whether it's mobile devices or any devices that are connected, there are a lot of interconnections between that. But that is the one aspect of it. But what about those devices that are actually used for critical infrastructure? Because we need automation at the end of the day, right? But is this a part of the secure automation? That is also the most important part that we really need to talk about. We talk about automation in all different applications. But at the end of the day, the question should be the secure automation. And that being said, what we have seen in this talk, we'll look into the web component of it. We have seen vulnerabilities. We have seen how the vulnerabilities are automated by attackers, and then how they are used for building malicious platforms. But at the end, we also see utilizing all that information in one go, we have found that several interesting critical infrastructure devices on the internet as well, which would be very, very disastrous if bad actors gonna get access to it. And that being said, what is the end result? I think this is the one I personally like the most, because this one, the message, I was talking in Hackers on Planet Earth 2 years back, and they have actually displayed that message all across in the conference. It's an important one. And what they say is security, right? We all talk about security. We have components, we need to secure, we have to stay private, blah, blah, blah. And they're saying it isn't new. The question here is that it is up to you, right? Security is there, home locks have been there for a long period of time. The advancement is in the way home locks are now built, right? But it is up to you. You can lock the house, but if you let the window open, who cares? It's just the entry point. And that's how you're still gonna get compromised, but you still have a false sense of security. I still have locked my house. And I think that's the way we need to look into it. That's where, when we talk about building security solutions or performing any kind of security assessments, we actually go after analyzing authorization boundary and the entry points into it. We just not only go by the front end, there are many other entry points as well. But interesting aspect that security is nothing new, but the question is that are we doing it, or are we doing it in the right way? I think that's what we really need to decide in this context, whether it's an IoT space or SCADA infrastructure. But the problem is that the threats in the IoT space are very real, and they are going to be a problem. They are still a problem, and they are going to be a big problem when the concerns and stakes are really high. And that being said, I think I've covered the content that I have. I'm open to questions. Love to discuss interesting ideas and your queries. If you have any questions, let's have it.
Are you seeing manufacturers get any better at building security and
See, I think I'm repeating the question again so that everybody
And
understands.
talk to me about the law in California as well around IoT security.
Yep. So in this particular case, there are two aspects to it, right? If you're building, so your question is that critical infrastructure, how they can enhance the security or what they can exactly do, if I'm getting it right. So the first part is that, there are two aspects to it. Software that you are building and it's a homegrown. There are different ways you have to look at it. Software that you are actually importing from the external vendors, there are different aspects to it. Because in the first case, the responsibility model changes. The entire responsibility is upon you because you are developing that component, and how security needs to be infused into it, it's your responsibility. But when you are importing a software from some vendor, it becomes a part of the shared responsibility. Vendor can play smartly and they can give you the certain options to configure those devices in your environment, but then under shared responsibility model, it actually comes back to you whether you're configuring it really well or you're just doing it from the compliance purposes. So that is where the problem is, and that's, I think, that is the efforts need to go into. How many times people read the documentation before actually deploying the device? I'm just saying an example, small thing. The most important detail is going to come from the documentation as well. But I think in that case, it's a shared responsibility model. In this case, the onus is on them and how effectively they are infusing security into the environment. Now, the second question with that IoT one that you asked, the California law, I think the interesting one they come up with, I'm not sure it is already signed, but the discussion is already in a place. Any IoT device or any kind of specific embedded device that vendor is going to sell, they have to actually enforce this functionality of, change the password right away. So let's say you actually deploy the device and you wanna try to log into it. As soon as you log in with the default password, they have to enforce you to actually go after and change the password right away. To just actually present one set of attacks, but how many are we doing it? But that also comes to the question whether how strong password you're setting it up. People still set up the password as a password or come on. So I think that is where it has to be looked into from all aspects. If you look at the security, it has to start from the source and it has to go to the end. And that's how I think we can build strong solutions.
And that's all that law was about, huh?
That was one of the most important parts.
Yeah.
Because they have to
practice and like do those in seconds. So I don't know.
At least
that's a whole lot.
You can see that this is still a good step to actually enforce that thing.
It's not default.
Yeah, just at least default is taken off the table. And few things from a regulation perspective here and there, but not much.
Okay.
Any more question? Yeah.
You mentioned about the cross-interface capabilities. Did you come up with any statistics or numbers or how prevalent that is? I mean, Telnet's not probably a real big deal, but there may be other interfaces.
Absolutely. I think if I'm just going to repeat your question, like how prevalent, Telnet interface is very much prevalent in the IoT devices. There are any other interfaces that we have which can exploit? I think, and I go a little bit into the model of there's a remote management interface, but then there is also an interface where the services are actually being consumed, right? The first one is that we're going to have a Telnet, we're going to have FTP, we're going to have SSH, we're going to have web. But Telnet, web, and FTP are the most prominent ones because they just give you the functionality to actually go after and access the device. Now with the service use is the kind of, that becomes very specific to different protocols like TCP-based service or UDP-based service. Right? But then in that case, it is very customized. These are the standard protocols, they make it very customized. So in order to understand that thing, there are some reverse engineering efforts to go into it. Because you can have some custom client, you can use the netcat query, netcat to actually connect to it, but you have to understand the low-level details. Because for example, in UDP, you need to actually dissect the packet, and you can still get password in some devices. But the question is that how you actually look after gathering the information from the device.
I saw a lot of, for DDoS, UPnP.
Yeah, UPnP, I mean,
lots of
I would say it is just the way it is being used right now. And for example, if you go back and you have like this, if I say Samsung, 7000, 9000 series, you can clearly see that you just trigger the sniffer in the environment. You can clearly see how UNPP and is interacting. I did some tests. I just simply wrote a code and I actually crashing by my Facebook app directly by hitting the server. And then you can do those kind of things as well. But PNP is the problem.
It's big.
Yeah, universal plug and play.
Thank you.
Yeah. Any more questions?
Yeah. So when it came to the scaling networks and ICS stuff that you played with, most of that was like actual machine stuff that's like outside of, say, like an energy facility, right? The reason I'm saying that is because like a lot of the stuff that's in the energy sector is not actually right based. It's on read only.
Yeah.
So a lot of people keep saying this stuff about ICS to be hacked, but then it's in irrigation systems, HVAC, I would agree, but when it's in energy, it's read only, it's not right based.
Yeah.
So, but you find a lot of web-based devices in that area too that are popping up.
Yeah. So I think I'm going to report basically repeat your question, and I think you're asking that in the energy sector, in the SCADA devices that are deployed in the energy sector, they are pretty much give you the read access and not the write access. I think that is true as well. The interesting part in that case is that even if you get a read access, let's say from a hacker perspective, you're still going to get a lot of information, right? And they can still connect the dots, right? How exactly the documentation will be there, this and that, and they start finding vulnerabilities in that context. Read information, I have seen that when in different water wizards and any kind of functionalities, like different devices, even the read access give you a lot of interesting information. For example, if you still have a read access, but there are certain critical components into it which are reading information like a critical token or some other kind of thing, or they have a link to some web resource, it's still read only, but still disclosing your sensitive password, still is a gain done in that case. But again, in critical infrastructure, there's not only one component. There's like many PLC controllers at the back end, how exactly the, for example, industrial facilities are being maintained. But the entirety in this context is that, even if you have a small thing open up, it can still give them the leverage to actually go after and attack it. And I think that's where they really need to look at. My simple question is that use the web interface. No, restrict it to your own environment. If you really can't do it, have it firewalls.
That's a stupid part,
And then you think, because people think there's nobody gonna look into it, right? You have firewalls, you have IDS, IPS, but then you're opening it on the internet, like the security is on you. That's the part. Anyways, thank you very much. I'll be around and we can discuss. Thank you very much.